Hello everyone, my name is Yash, and today the topic on which this project is done is resource management and allocation system, designing a comprehensive system for managing and allocating system resources like CPU, memory and input output devices. This C++ program implements the banker's algorithm, a cornerstone method in resource management and allocation system. The banker's algorithm helps in managing and allocating system resources such as CPU, memory, and input output devices efficiently. Its primary goal is to prevent deadlock by ensuring system remains in the safe state even as multiple processes request and release resources dynamically. So the detailed explanation is basically initialization and input. So first is resource and process information. The program starts by taking input for the number of resources, count of R, that is basically count of resources up to 5, and the number of processes, count of P, up to 10. It then asks the maximum instances of each resource available in the system. Secondly, it goes to the allocation and maximum demand matrices. Third, it calculates the need matrix, basically forming a matrix which is almost needed. Display the input data. The program prints out the total resources in the system, the allocation matrix, the maximum demand matrix, and calculated need matrix to provide a clear overview of the current resource allocation state. Safety check using Banker's algorithm. It iterates through each process, checking if it can satisfy its remaining needs with the available resources. If the process can be completed, it is marked as finished and its resources are released back to the system. This process continues until all processes are completed or no further process can be completed, indicating it's an unsafe phase. Finally, the program outputs whether the system is safe or unsafe state. If the system is safe, it prints the safe sequence for the process execution, and if it's unsafe state, it basically prints out unsafe sequence. Relevance to the source management and allocation are given. So basically now we'll directly go on to. Now we are here again with coming back to the coding section. So basically let's dive into it. So this is the code which is needed for the basic resource allocation program. Now we'll start by explaining it. The include iostream and conio are basic header files for this program. Include iostream includes the standard input output stream library to use the cout and cin. Include conio.h includes console input output function, specifically getch, for pausing the program until the key is pressed. Using namespace std allows us to use the standard library names without prefixing std. Now the main function is basically the entry point of the program, so which can basically start the functioning of the program. So now the instance phi, maximum instances of the each resource type. Count is used to keep track of all number of processes left to check. The sequence stores the safe sequence of process execution. The safe is a flag to indicate the system is safe state. Index for the sequence array is S. J and I are basically loop counters. Completed is a flag to indicate if a process can be completed. Now the available instances of the resources allocation is the allocation matrix representing resource currently allocated to each process. Need matrix is a representing remaining resource needs of each process. Process is not used in the program. Count of R, the number of resource types. Count of P is the number of processes. Running, array to keep track of the whether program is still running. Maximum demand, maximum demand matrix representing the maximum resources each process may need. Now the cout is a thing which prompts the user to enter the number of resources types, that is less than 5. So secondly, the input maximum instances of each resource. The loops this loops through each resource type, asking the user for the maximum instances and storming them in instance I and available I. That is, input the number of processes. This prompts the user to enter the number of processes which are basically less than 10. Input the allocation matrix. Now the input of the allocation matrix prompts the user to input the allocation matrix, which represents the resources currently allocated to each other. The available resources are updated by subtracting the allocated resources. Input the maximum demand matrix. This prompts the user to input the maximum demand matrix representing the maximum resources each process may need. Now the display input data. This program section basically displays the total resources in the system, the allocation matrix and the maximum demand matrix. Now calculating the number of display and need matrix. This calculates the need matrix as I as need of I. J is the maximum demand of I j. Allocation ij displays the need matrix. To check if the system is in safe state. Now the program section basically checks and prompts the user if the state is safe and waits for the key to press to continue. Now initializing the running array and count. This initializes the running array to mark all the processes as running. It sets the count to the number of processes. Now the safety check of the loop. Now this programming section checks the basic safety check loop. This loop until all processes are checked, which is from starting count is 0. Checks if the current process can be safely completed by comparing its need with the available resources. If a process can be completed, marks it as not running, updates the available resources and adds the process to the safe sequence. If no sequence process is found, it breaks down the loop. Now it prints the result. Now basically printing the result includes the system is in safe state or the system is in unsafe state. Safe state or unsafe state basically. So after this, the program basically completes its iteration and finally coming to the point where we actually need the resource allocation to be finally taking place, and then we use this for the help. So basically I'll show you by running this. Firstly we'll try to run and use it in the safe state. Now let's try to run it. So now the basic program compilation is successful and the program is running. Now it asks us for entering the number of resources, which is less than 5. So let's enter 3. Now maximum instances of resource are 0. We'll try to enter 10. For resource 1 we'll enter 5. For resource 2 we'll enter 7. Now it's asking us to enter the number of processes which are less than 10. So basically let's take 5. So it's asking for allocation of resource R0, we'll enter 0. We'll take the first resource as R1 as 1. We'll take R of 2 as 0. Now it's asking for the process P1, allocation of resource R0 as, we'll enter as 2. For R of 1 we'll enter as 0. For R of 2 we'll enter as 0. For the process P2 it's asking for the allocation of resource R0, we'll take as 3. For R of 1 we'll take 0. For r of 2, let's take 2. Now for the process 3, it's asking for resource allocation r. So for r0, we'll take it as 2. For r of 1, we'll take it as 1. For r of 2 also, we'll take it as 1. Now we'll take for the process 4, resource 0, we'll take it as 0. Similarly for resource 1, we'll take it as 0. Similarly for resource 2, we'll take it as 2. Now it's asking for the matrix, max matrix. Now for the max matrix, we have to enter the process P0, and now it's asking the maximum demand resource R0. So now let's enter as 7. For R1, let's enter as 5. So now it's sorry, there's been a mistake. So let's run it again. Now after running the program again, it will take a little bit of time and then finally successfully run. So as we start, basically we'll go till the process we were already in. So let me enter it again. 5 7 5 0 1 0 2 0 0 3 0 2 2 1 1. For other it was 0 0 2. Now we were in this section, so basically we'll enter for the maximum matrix process 0. The maximum demand resource R0, we'll enter it as 7. For the R1, we will enter it as 5, and for the R2, we'll enter it as 3. Now for the process P1, it is asking us to enter. We'll enter it as 3. Second will enter as 2. Third will enter as also 2. Now for the process P2, we'll enter the resource, that is 9, 0, and then again 0. And process P3, will enter it as first resource as 2, again 2, and then again we'll enter it as 2. So now it's asking for the last process P4, that is 4, we'll enter it as 4. Second will enter as 3. Third also will enter as 3. So now after entering these all in the allocation matrix, the maximum matrix, the given data are total resources in the system, that is R0, R1 and R2 are 10, 5 and 7. The allocation matrix is shown as this one. The new matrix, that is max matrix, it is shown as this one, and the needed matrix which will need is this one. Now to check whether the above state is safe or not, will be requested this one sequence, and we have to press any key to enter to check if our given sequence is safe state or not. So let's enter and continue. So now basically this is running the process P1. The total resources now available are R0, R1 and R2, that are 5, 3 and 2 respectively. The running process P3 is basically total resources now available are 7, 4 and 3 for resources respectively. For the next process, it's running process P0. the total resources available are R07, R1S5 and R2S3. The running process P2, total resources available are R0, 10, R1, 5 and R2S5. Running process 4, the total resources now available are R0, R1 and R2, that is 10, 5 and 7 respectively. So this shows us that the system is in safe state, and the safe state sequence is given by P1, then followed by P3, followed by P of 0, followed by P of 2, followed by P of 4. So this gives us a safe state sequence for completing the process by allocating resources for its respective places. So now this is the program output for basically the save sequence. Now we'll go to the coding section. So this is basically the whole code for this resource allocation program. We've explained this in a better manner so that we'll be able to understand what's happening after the program is run. So this is the whole sequential matrix method formulation, and it helps in the process which is need to be solved. So now let's basically run this program. So it takes a little bit of time. So after running the program, we'll get the cout statement as this. So now we'll basically enter the values. Now we'll enter the first value, which is less than 5, as 3, the second value 10, here 5, 7. Now we're basically putting the values which will form a safe state sequence. So we are getting it for the safe state sequence first, and then we'll try it for unsafe also. So first is safe state. Now for less than 10, we'll enter as 5, second as 0, 1 and 0, 2, 0 and 0, then 3, 0, 2, then 2, 1 and 1, 0, 0, 2, 7, 5, 3, 3, 2, 2, 9, 0, 0, 2, 2 and 2, 4, 3 and 3. So these are the basic outputs of allocation matrix, need matrix, max matrix and need matrix. Now for checking if the sequence is safe state or not, let's enter. So we'll get the total resources now available for every process, and it forms a safe state sequence also. So basically this is the output. The system is in safe state, and the sequence is P of 1, P of 3, P of 0, P of 2 and P of 4 respectively.